Let me make two notes on the interpretation of interaction terms. The first note is general, and the second note is specific to ex post explorations of treatment heterogeneity. Now, let's take as a starting point a randomized control trial, for instance, Alcott treatment, and then we estimate an average treatment effect, alpha 1 here in this estimation equation, and obviously this alpha 1, this average treatment effect, is directly policy relevant because the treatment is an intervention variable. That is something that you can manipulate and that Alcott did manipulate. So you can either provide households with those home energy reports or no. And interaction variables tend to be different beasts. Those tend to be non-intervention variables. Those tend to be characteristics that we tend to have data on. For instance, in the case of Alcott, it is pre-treatment use of electricity, this term high. And say, as Alcott did, that you find this interaction term to matter. So the term alpha 2 is substantial in size and is also statistically significantly different from 0. Then the policy relevance of alpha 2 is not in being able to directly influence this term high, obviously, because pre-treatment use is not an intervention variable. You cannot simply turn households from high use to low use of electricity. And those two groups, so the high and the low group, they differ in many ways. So high users may be younger, for instance. They may have a different attitude towards the environment than low users. They may live in a different type of home. They may have a different type of occupation that, for example, affecting the number of hours that they spend at home. They may have a larger household, so with many kids and all that. So this term high is actually an amalgam of many factors driving this pre-treatment use, and obviously this is not something that we can directly manipulate. Now, that doesn't mean that the interaction term is not policy relevant. The relevance is actually in some other dimensions, namely, for instance, in being able to target the treatment on this specific group. And secondly, as we will discuss in week 3, it helps us to understand the mechanisms that are at play. Another note is that the term alpha 2 here, showing how the marginal effect of the treatment varies by values of high, may well be context specific. Say that all our data are based on households in metropolitan areas, then this interaction term may actually not be a good guide for how the treatment effect varies among groups of users in more rural areas. Okay, so that's a very general note on the interpretation of interaction terms. Secondly, there's something specifically dangerous about ex post explorations of treatment heterogeneity. And remember, so the idea is that you have to run your experiment, and now you're like, let's see whether the treatment effect varies by age, and let's see how it varies by gender, or what have you. And the danger is then that look, we all like to report statistically significant results, and I observe that also many times among master students when they write their master thesis, then seeing stars in tables, that many stars being estimates that are highly statistically significant. And that's always nice. So say that you estimate the effect of a treatment or of a policy or what have you in your thesis, and you don't find much, and so you cannot reject the null hypothesis of no effect. Then it is tempting to say, well, given this result, why don't we go towards exploring heterogeneity, and maybe we do find something. Now, the trouble is then that there's always a chance of then finding something. If you have a large bag of interaction terms, then most likely you will find some interaction term to be statistically significantly different from 0. So, but those are called sort of fishing expeditions, or an alternative term is data mining. So you just look at many different interaction terms that you happen to have data for, and then you report, you selectively report actually the interaction term that you find to be statistically significantly different from 0. However, then there's this chance element that you do not take into account. So let me actually give you an example. Say that you have 10 covariates to play with. So you have a treatment and you happen to have data on 10 pre-treatment characteristics of subjects in your experiment, and they're all uncorrelated. Now, also assume that there is no real treatment effect on average. Well, and actually for all units, so there's no unit level treatment effect. Then the chance that you do find some interaction term to be statistically significantly different from 0 at the 5% level is actually 40%. So there's a 40% chance then that you find one or more of those interaction terms to be statistically significantly different from 0. But that is obviously just chance. So you will have to correct for those, for testing multiple hypotheses. And one of the ways of correcting is to use the Bonferroni correction. It's actually pretty conservative, but I use this as an example because it's a very straightforward correction. So the whole idea is that say that you test 10 different hypotheses, then you also have to divide the p-value that is your target. For example, to say that you look at a p-value of 5% or lower, then you divide this by the number of hypotheses, in this case 10. So then the threshold level for reporting a statistically significant effect for an interaction term is only 0.5% rather than 5%. Now, so say that you see a difference in the treatment effect to depend on the value of an interaction term, and you ask whether that is just chance or whether that is real. Well, then the answer is it is impossible to know if we do not know the number of interaction terms that the researcher considered. And this is a very important note, because say that you see a paper and you read through it and you see this interaction term to be statistically significantly different from 0, then you have to regard that with skepticism, because if the author is not very clear on how many interaction terms he or she really had, then this may be a chance finding, right? And say that you're an author, so you're a researcher, and you have a strong belief that the treatment effect should vary by some interaction term, for example, some pre-treatment level of the outcome, then the trick is how you are going to convince the readers that you did not go on a fishing expedition, but that you just tested this one interaction term. So how are you going to commit yourself to successfulity? That is the topic of the next and last video clip.